Okay, good morning, Professor Eza. Okay, this is my AI Cloud piece number 9. I want to present you my homework. The objective for my dataset is to liver cirrhosis survival prediction. The objective here to predict the survival state of patients with liver cirrhosis using 20 clinical features. I show the target variable here is 30, survival of patient. I encoding this variable 0 when the patient die, 1 when the patient survival during the stage period, 2 when the patient censored due to the transplantation. The dataset characteristic, we have the tabular type, the feature, we have the numerical feature and categorical feature. We have the 418 row intents and 20 variable the features. The purpose of dataset, the cirrhosis result from prolonged liver damage leading to extensive scarring. Okay, my work for my work, I start to import the necessary library, like warning, request, and zip file, and IO. Because I want to scrap my dataset link directly on the website site. That's why I import this library. I import this because sometimes I need to clean this, to filter my dataset. I import pandas because I want to make I will make the many manipulation on my dataset, like round drop, add, filter, everything. I download my dataset and extract. I copy and paste my link dataset here. I send the request for this function here, function get request get here. I create a zip file object and download the content. Then I extract my file. Here I load dataset here. This here the file. I decide to display the first few rows on the dataset here. You can see the variable here. We have the ID, everything. We have the 20 column, 20 variable. Here I try to make the descriptive analytic here. I describe my dataset. You can see the mean here for each variable, standard deviation, minimum, first quartile, second quartile, and third quartile, and maximum here. Then I try to verify the dimension of the dataset. I have 418 row and 20 column. Here, I decide to remove the ID column because it's not necessary for us for the future work. She don't give me the necessary information. Then I try to, you can see the new dataset here. When we drop the ID column, we have now 19 variable. You can see here we have the missing value here. So you can see everything is missing value. We try to drop or input something like for each index here. Here we try to count the number of missing variables. For example, we have here for this variable we have a 106 missing values here. The data tab is integer here. Here, because we have the category variable and numerical variable, we decide here to make the imputation. for category variable. You know, when we want to make the imputation for category variable, we use the mode. That's why I use this function for to make the imputation in all category variable. This script, I try to filter. I try to make the imputation with the mean because we have the numerical variable here. Here, I try again to display my data frame. Okay, I show this variable, the cholesterol variable, because I want to calculate the earlier. I use because we have different methods. I chose to do this method here. I calculate the first quartile and third quartile and lower bound and upper bound. I try to detect the earlier for this column. Okay. I change the earlier to display here. So again, yes. Here I put this function for column here to log over all numerical variable of every column here. I try to detect the audio for every column. I use the same method. I calculate the interquartile range. I define the lower and upper bound for audio detection. I try to identify the row where value are outside the bound. If I see any value outside the bound less than the lower bound or over the upper bound, we consider that this is the okay. Okay, well, for this function, I use this function to remove every value for all numerical column. I use the same method where I define the lower bound and upper bound here. I calculate the difference for every value here. I display my data frame here cleanly. I define the mapping from categorical value to numeric. I map here because I want to make the encodation, the auto encoding here. The auto encoding here, you cannot make the label encoding here because the category because I want to change the category variable to numerical variable. It's not original. So here I change, for example, yes, and code to 1, no, and 0, present 1 again, 0 here for all numerical value for every column. I replace the initial value by 0 here to convert to integer. Here I try to display the name of all non-numerical variable here. I have it statue with hawk here. We have data type in object. This means that we have the characteristic. The characteristic chain is not integer. Same here, I define the mapping for target variable statue here. 0 when the patient die, 1 when the patient can survive, 2 when the patient has a transplantation. I apply the mapping here for the statue because statue is my integer, my target variable, my label. So I verify the occurrence for each class here. I have 0, 169, 64. Now we are the integer data here. I try to encode the column category variable to have access here. I display my dataset here. About the birth certificate, because the birth certificate, when we open the first time our dataset here, the birth certificate, the birth date column here is not the is display the wrong format. So we try to convert this format here to have the good format. That's why we use this function data here. Import data from home. So here the date here is characteristic here. Here now we import the function here because we want to stratify. We want to stratify the dataset here. Our dataset. We want to stratify. We use 20 dataset with the testing, 80% with the yes, 20 tests for the test, 20 for evaluation. Here we define the target variable, define RG. We stratify the feature here. We try to stratify. After we stratify the variable, we can see here we have the row. How many rows we have here? And for this, we had a 20, 5 line, and 22 columns for this here. Provided we had 22, 25, everything. 22 column because first time we have a 20 column, but when we change the variable, we add 2 column here. The bird did everything, yes. Now for feature selection here, we try to select the best feature for your work for our work. Yes, I use this method. I use the deep method here, random forest, to reduce your dataset, to reduce the dimension. Now here we can see that this method help us to select 5 features, 5 column here, and then we have for train we have the 188 row and 5 column. Here we have the 48 row and 5 column here for test for extend text. So then we import the map polyp because we want to display the feature that we select before. So here we can see that this is the best five features that we select here because it's so more representative. Here we combine the select training features and target variable here because we want to merge every features here for train and same for test your target and features, target variable and features. Here we define the file name for the saving dataset. Define trend CSV and then we download here. Now we want to stop to go to make this stockage our work on the Amazon S3 here. That's why we we got first our bucket here. So I came for bucket, I come here, I tap Amazon S3 and copy this line. This is my bucket here. I train here validation test, everything done upload here. Very good. So we try to stock here to save the file dataset in the folder S3 on Amazon Web Service. Here we try to display the dataset here. We train 70 training, 15 validation, and 15 test. Okay, you see the result here. Yes, we have the class distribution for each set here. For training, we have 17 for this statue here, 22 for this statue, for statue 0, everything. For validation, we have same thing here. For test, we have same thing for the 3 class. Here, we try to train the model here. We use the random forest, we make the 100 estimator here. Yes, we got the metric here. For the precision here, we can say we had a set, for example, for this class, we have a 17% predicted here, specified only actual value predicted. Here we have the harmonic means for this predicted. Here we can see for the matrix confusion here, you can see the diagonal here. We had a 6 predictor, 6 class predictor here, and we have 5 misclassified here. We have 0 error here. Same here, we have 32 prediction here, and 1 misclassified. Here we don't have a prediction. So thank you for understanding.